All right, we're going to keep doing these until we understand completely how this works in every scenario that we could possibly come across. Because next class, we're going to be applying this to word problems. And once we involve the word problems, we can sometimes lose sight of what we're actually calculating. So if we concentrate this week on just calculating the values here and understanding how to do that, then I think we're going to set ourselves up well for next week. So 2.58. 2.58 is right about here. 1.23. That's right about here. Okay? We want to find this area right here. So to do that, we want to find the area below this value. So all of this area below 2.58 and then we're going to subtract from that this area right here. I think you get the idea. Oop, got a little crazy there. All right. So we're taking all of the yellow and subtracting the green, and we'll be left with just this area right here. So again, what we're doing to find this probability is we're taking the probability that z is less than 2.58, and we're going to subtract from that the probability that z is less than 1.23. So we're going to do norm.dist. It's going to be 2.58, comma 0, comma 1, comma true, minus norm.dist 1.23, comma 0, comma 1, comma true. And that gives us about 0.1044. And again, if we think about what's really happening here, we know that this region is between 1 and 2 is 13.5, so 0.135. And then this whole region here is another 0.235. Okay, we're not quite covering all of the 0.135 or all of the 0.235, so we're not going to be quite at the 15 point or 0.15 that we would be at. And so we expect something in this range. It's just good to check, like, what would you expect to do if we were using the empirical rule? What's the biggest value that I would give, and what's the smallest value that I could give? And sort of come up with a range in your head of what you know the values is going to be, so that when you get your answer and it's way off from what you thought, maybe you can realize that you typed something in incorrectly. All right, let's do another one just like that. So this is going to be negative 1.14 all the way to 2.31. And it's the same idea. We're going to take the probability that z is less than 2.31, and we're going to subtract the probability that z is less than negative 1.14. So I don't need to draw this again. It's the same idea. We take the bigger area and then we subtract out the smaller area from it. So in this case, we have, and I'll move this over a little bit so we can see the whole formula. We have normal dot dist, and we end up with, we have the 2.31, comma 0, comma 1, comma true, minus norm.dist, and we have negative 1.14, comma 0, comma 1, comma true, and that gives us 86.24 or 0.8624 as our value. All right. So I want you to pause the video and try to do these last 3 on your own, and then you can unpause it and I'll work through them with you. So pause the video now. All right, let's see how you did. So we have the probability that z is between 0 and 1.17, okay? So this one's a little bit different. I can approach this one a little bit different. I can still do the probability that z is less than 1.17 minus the probability that z is less than 0. But I already know the probability when z is less than 0. It's 0.5. So I can just find the probability that z is less than 1.17 and then subtract 0.5 from it. Now again, it's nice to have an estimate. I'm thinking this is 34%. So this is going to be close to, like, I don't know, 40%, let's just say. Okay, so 0.4%, or 0.4, sorry. So again, I'm going to do norm.dist. I'm going to use 1.17, comma 0, comma 1, comma true. Now this should be, so this is 87.8 or 0.8789. If we subtract 0.5 from that, we're gonna get, oh, okay, I said 0.4, it's 0.378 or 0.3790. So that wasn't too bad. So now the probability that z is greater than 2.56, that's going to be 1 minus the probability that z is less than 2.56. Oh, I already did this one. It's up here. Forget this one. All right, let's do this one instead. So we want the probability that z is greater than 6.89. So again, that's going to be 1 minus the probability that z is less than 6.89. But let's just pause for a second and think about what this means. Where is 6.89? Well, 6.89 is way over here on this graph. Now we know that below that value, we're pretty much covering this entire area, which is 1. And so I'm thinking that the probability that z is greater than 6.89, that's going to be 0, right? Or really close to 0. So let's go ahead and calculate that and see if my hunch is correct. So we're going to do 1 minus norm.dist. We're going to do 6.89, comma 0, comma 1, comma true. And what do we get? We get 2.789 times 10 to the negative 12, which is 0.00000000278. Let's just call it 279. So I said it was going to be like 0. This is pretty much 0. And that's okay. I mean, is there a possibility that we're going to find this value? Yes, probably not in any of our lifetimes. But if you had said 0 here, I'm going to say, all right, that's good. You're okay. All right, so that's all from this video. I'll see you in the next one.